So here you have problem number 5. When current throughout a circular loop is 7 ampere, magnetic field is at its center is, please give what is the radius of the loop. Now this time is different structure. This is problem number 5. When we have a loop of the wire, and let's say the current is flowing in this direction, you have to use your right hand rule, and your thumb will be the direction of the current, and your forefingers will be the direction of the magnetic field. So in this case, magnetic field at the center will be out of the page, okay, using the right hand rule. So in this case, we have different formula where B magnetic field is equal mu I as usual, but in the below it will be 2R, okay, there's no pi. So from here you have to find R, basically mu naught current divided by 2B. Mu naught is 4 pi times 10 to the power of minus 7. Okay, problem number 6. When a current throughout circular loop is 6 amperes, magnetic field at center is, what is the radius of the loop field? So basically this is almost the same problem, seems. Okay, problem number 7. How many turns must be wounded on a flat on the flat circular coil of radius in order to produce a magnetic field of magnitude at the center of the coil when the current throughout is 6 amperes? Okay, so we have to find number of turns. So problem number 7, we have the radius is given, what is 20 centimeters. So we have again this kind of wounded wire, like many turns. Let's say the current is going in this direction, and magnetic field obviously in the center will be out of the page, using the right hand rule. Then we have to find B is given, I is given, so we have to find number of turns or wounds on this circular wire. So again, use the previous formula where B is equal mu naught current divided by 2R. The only thing is changing here is number of turns has to be multiplied here. So that's it. Then number of turns will be equal to the 2BR divided by the mu naught current. So again, mu naught is 4 pi times 10 to the power of minus 7. Okay, what is next? 7 is finished. Problem number 8. So we have superconducting wire of diameter. Superconducting wire of diameter carries a current kiloamperes. What is the magnetic field just outside of the wire? Okay, we have to find just outside of the wire, right? So let me write down. So the diameter is given 0.25 centimeters. Again, all has to be in SI unit in meters. The current is 1 kiloampere, so it will be 1000 amperes. We have to find the B just outside of the wire. Okay. So if the radius is equal d over 2, then we also know that if this is a current, we know that it will produce magnetic field everywhere. We have to find just outside of this wire. So let's say this has a certain radius of the wire. So the formula will be B is equal mu naught current divided by 2 pi R. Okay, so that's it. Then your R is equal d over 2, which is mu naught current, 2 pi d over 2, so it cancels out, so end up with mu naught current divided by pi d. That's it. You put the numbers and you should get the answer. Okay, what is next? Problem number 9. We have a solenoid is wounded with 2000 turns per meter when current is 4.3 ampere. What is the magnetic field within the solenoid? So in the solenoid you have particular formula. Okay, first let's write down things. Problem number 10 or 9, I don't remember. So it has 12 turns per centimeter, or I don't remember, but this is basically the N. Okay, then we have magnetic field is given. We have to find a current. For the solenoid, you always should keep in mind that the formula will be B is equal mu naught N current. Now N is that one, so mu naught is 4 pi 10 to the power of minus 7. N is 12 turns per centimeter. Again, it has to be converted in the SI unit. Turns per meter it should be, okay? And you can find a current where B is equal mu naught N, okay? Next problem. In the next problem, you have what is the current? So basically, number of 10 or 9. In both cases, you can use the same formula, which is this one, and you can solve any of them actually.